We got introduced to the universal law of gravity. So what does it tell? The force between two objects, say of mass m and m, kept at a distance of d, has a gravitational pull which is given by this formula. That is F is equal to, please do tell in your head, F is equal to capital G m into m divided by d square, where capital M and small m are the masses, d is the distance between those two objects. What is this capital G doing? This capital G is your proportionality constant. It's a constant value and it's not equal to 1, unlike your F is equal to ma, wherein the proportionality constant happens to be 1. It's not so over here. Here the constant is 1, by the way. Over here it's not. It is actually equal to this particular value. Should you memorize this? That's a question which your teachers will be answering, because as of now the policy is something and it might change in the future. So you guys have to discuss that with your teacher and come to a decision if you have to memorize this or no. Okay, all of this is okay, but why is that I'm making a separate video just for this value? Well, the way they found out this value is kind of unique. I liked it, and I'm sure you guys will also like it. So the experiment done to find this was Cavendish experiment, and the setup is as simple as this. Again, the experiment name is Cavendish experiment and the setup is over here. It's an easy setup. The one they had, of course, would have been more complicated, and but to put it in the simplest manner, I have this. So we have a platform, a stable platform. Hung from that is a thread, and to this thread they had a mirror attached. The mirror was attached so as to measure the angle. How is the angle useful? All that I won't go to the detail. I'm just trying to explain how the setup was. And attached at the other end of the thread was a stick, and end of the sticks were two lead balls. And what they did was they took up two spots at equal distance from these two lead balls, and at this two spot they kept another two lead balls. They were a bit bigger. What happened? The system was stable. Initially they saw that these two were not moving. This system was not moving. This was at rest. They waited till that point, and then they kept these two metallic objects, heavy things. What they saw was things which were stable started moving, right? And with the help of this setup and with this motion, they were able to find the value of G. You might be still wondering, how is this possible? Well, with this particular setup, you are able to find the force. Okay, how is that? It has to do something with torque. Torque is something that you guys are not introduced to, so I can't go to the detail, but I'll help you guys understand this. They found out the torque. Okay, so what is this? You guys can web search. That's why I'm writing this. So with that, they found out F. Obviously, they know the mass of capital M and small m. Okay, so capital M and small m, they know that. Obviously, they know the distance because they measured and kept it. So they know D also. All of this is known. The only thing which is unknown is G. So what can you do? It's a simple linear equation. So G is equal to F into D square divided by small m and capital M. Substitute the values over here, and thus they were able to find the value of G. Okay, that's it, as simple as that. To help you guys, make you guys realize that it's a very easy setup and you get to see something nice. That is, you get to see gravity between two things which you would have not been able to observe. Even the smallest thing possible out there which has mass has its own gravitational pull. Right? To make you guys realize that, to make you guys see this, you guys can also do the setup. So all you have to do is have this thread and all of that attached to metallic ball, right? Or any other ball, not metallic only. I made it out with some clay material. Actually, not clay. That it is quick fix, not quick fix. Okay. Anyways, I'll write it below somewhere so that you guys can buy that. I'll write it somewhere along the video so that you guys understand what material I used. So it was a bit heavy. I could make a ball out of it, and then it becomes hard. Not quick fix, something that is used for all this pipe, uh, like bandage to the pipe so that it does not leak. Arey yaar, I forgot the name. It hardens when it dries. Okay, so I made it out of that and I kept a dumbbell and it started moving. Oh yeah, and by the way, I kept the system for a day. Means I kept it overnight so that it becomes stable. What becomes stable? These things which are hung, without the, yeah, only this. I let it be for a night so that it becomes stable in an empty room, in a room wherein there is no disturbance, basically, no wind and nothing. So I let it be. You guys can let it, set up this and let it be for an hour or two so that it becomes stable. It should be at rest. And then keep the dumbbell or something. I'm sure you guys will have something which is heavy. Keep it near and it'll start moving. Okay. So the fundi here that you guys have to observe is that motion. And what is the big deal? Well, something which was at rest, according to first law, it has to be at rest. The first law of motion tells that it has to be at rest. If it's moving, what does it mean? It got accelerated. If something gets accelerated, what does it mean? There's a force that is present around that. I mean, acting on that, not around that, acting on that. So where did this force come into picture? It's because of gravity. Right? To promise you guys that I didn't do any gimmick. Actually, you guys can do it at home also. So you'll see that it's not a gimmick. The material that I used were non-magnetic. So you guys can have a look at this video to make you guys realize that it's not magnetic. Okay, please have a look at this. You guys saw that they were not magnetic, right? And now you guys have a look at this video to help you guys get a glimpse of how you can have the setup, and also that the gravity does exist. Gravitational force does exist, and this is the proof. Right? So I hope you guys are able to replicate this at your place as well. Okay, so let me just recap, but not over here, with the help of an example. So I'll be doing two things. One is we'll look into the question of why is that ant which has mass and you guys also have mass, why don't you guys attract each other? We do attract each other. We attract ants, and an ant attracts us. The question is, why don't we feel it? So let's answer that question and let's recap whatever we learned. What is the gravitational force between a person who is of 50 kg and an ant which is of 3 milligram? And the distance between their centers. Okay, I'll just take them as a centers, 5 centimeter. Right, a very close objects. Why don't we feel the mass? To answer that, we'll make use of universal law of gravity. Sorry, I'm not writing it neat. Let me write it neat. Universal law of gravity. So what does it tell? It tells that the force between two things, say in this case capital and small m, at this particular distance, the gravitational pull between them is given by this particular formula. Here capital M is 50 kg, G is 6.673 into 10 to the power of minus 11 Newton meter square by kg square. Capital M is 50 kg. We don't need to convert this to units. From here we have to convert. Small m is 3 milligram, which is 3 into 10 to the power of minus 3 gram. If you have to convert a gram to kg, we should divide with 1000, and 1000 dividing with 1000 is nothing but 10 to the power of 3 kg. So you do the math, it will be 3 into 10 to the power of 3 into 10 to the power of minus 6 kg. Okay, all this is well and good. What else? D is 5 centimeter, which is nothing but 5 into 10 to the power of minus 2 meters. So all the units are in their standard SI units. It's very important for you guys to understand that converting the units to the right SI unit is very important before doing any calculation. And now the working. So F is equal to, okay, I think I should start over here. F is equal to 6.673 into the power of minus 11 into 50 into 3 into 10 to the power of minus 6 divided by, this entire thing is actually divided by 5 into 10 to the power of minus 2 the whole square. Now on to the next step, that is getting all the numbers at one place. 50 into 3 divided by 5 square is 25, and all the exponent parts on the other end. As all of this is multiplication and division, I can do this. 10 to the power of minus 2 square is 4. Okay, all these small things I won't be able to show and explain. You guys have to get better at your calculations. So please see that you learn how I got 25 into 10 to the power of minus 4 in the denominator. Okay, so I can reduce this, and this is 6 into 6.673 or 6.7. So you guys have to somehow do this first, and that way is just multiply 6 with 6.7, and this is 40.2 into 10 to the power of, this would be minus 11 minus 6 plus 4. Again, all these are exponential formulas that you guys have to be familiar with. This is nothing but 40.2 into 10 to the power of minus 17 plus 3 or minus 13 Newton. It's a very small number. 0.123 123 123. This is 9 10 11 12. Okay, so we have 1 2 3, oh yeah, 04, my bad, 02. So this is 1 2 3. Okay, now it's correct. Very small value, so many Newton, right? To compare it with something which you guys are a bit familiar with, say 1 gram of something is 10 Newton. 1 gram of something on the surface of the earth is 10 Newton, and the force between a person of 50 kg and an ant of 3 milligram is this much. So you can clearly see it's a very small number, and that's why we don't feel any pull. Okay, I hope the concept and the idea behind gravitational law is clear, and you guys can do good numericals on this, right? So I would like you guys to draw all of this, try this setup. It's a very simple set of things, materials. So you can make this at your place and observe gravitational pull between two things which you guys would have not seen before. This number is something that you guys have to write it neatly, and the units as well. Okay, so units is quite simple. So you can see G over here. G is F d squared by m into m. So unit of force is Newton. Distance is meter. So distance square is meter square, and the mass is kg square. Right, and so the units. Okay, you can derive the unit from the formula itself. Yes, that is possible. And okay, you guys copy this first. Do try this at home. And the numerical. Okay, so I hope you guys understood two things. That is how to calculate with such weird numbers. And the second thing is that why don't we feel the force that is exerted by an ant on us, and why doesn't an ant feel the force that we exert on it? Right, guys? Chalo, you guys copy this. I'll see you guys in the next video.